Guys, in example 12, we're going to be determining domains, ranges, and whether something is even a function. And so in both of these examples, we definitely have a relation. A relation is just something that links two variables together. So we definitely have a relation, but we're asking ourselves, do we have a function? What is the domain of the relation? And so forth. So we'll start with domain. Domain. And those are going to be like this, x. So those are our x values. And what we're going to do is we're just going to go down the line. And if you have a highlighter, especially if you have two highlighters, two different colors, this is really, really helpful. And we're just going to copy down those numbers. Now, if you can organize them so that they're least to greatest, that's awesome. So -3, -2, -1, 0, 1, 2, 3. Okay. Now, you could have also, because it's going from -3 to +3 and it's not skipping anything, you might ask yourself, could I do -3 greater than or equal to x greater than or equal to 3? That's an inequality, a double inequality. Well, you can't do this because that's including all of the numbers that are in between the whole numbers as well. And we're given a very specific set of numbers that we're allowed to use. And that is the integers that you see listed there. Now we'll go into the range. And those are going to be our y values. Let me see. Put in a new highlighter. Let's do blue. Okay, so we have 27, 8, 1, 0, 1, 8, and 27. Okay, so let's write down our numbers, but we're going to write them down least to greatest. And so 0 is our least. Then we have 1, and we have 1 come up 2 times. We're only going to put 1 time. And then we have 8. 8 comes up twice. We're only going to put it in there once. And then 27. 27 comes in a couple times, but we're only going to put it once. So that's going to be our range. So again, our domain and our range do not have to be the same size sets, but we just want to make sure we're ordering them from lowest to greatest so it's easy for me to grade. Now let's talk about a function. Function. Are all x values unique? That's kind of our baseline. Are they all unique? In other words, do I see -3 come up on the list more than once? If I do, then it's not a function. If all of them are unique, then I can say yes, this is a function. Now, do all y values have to be unique? No, absolutely not. We had, let's see here, we had 27 come up on the list twice, once, twice. We had 8 come up on the list twice. We had 1 come up on the list twice, and that's fine. We can have that. But are all the x values unique? In this case, yes, they are. This is a function. So let's look at the domain of the next one and pay close attention to figuring out if they are all unique. So we have 9, 4, 1, 0, 1, 4, 9. So our domain, so let's, yeah, okay. Our domain is going to be starting at the bottom, 0, 1, 4, and 9. But notice that there are some repeated values. So 9 comes up more than once, 4 comes up more than once, 1 comes up more than once. That's going to be important to understanding whether this is a function. Now our range, that is our, and I forgot something up here. Let's do that, okay, our x values. Our y values are, let's go ahead and take a look at our y values. So we have -3, -2, -1, 0, 1, 2, and 3. So again, we'll start there at the bottom. That is 0. Oh, nope. We're going to start at -3. -3, -2, -1, 0, 1, 2, and 3. Okay, so function. Are all x values unique? Well, no, definitely not. We already talked about this. 9 comes up more than once, 4 comes up more than once, 1 comes up more than once. No, there are repeated values, not a function. So guys, that's it. That's how you do it. You look for repeated x values to determine if it is a function. If all x values are unique, you're good to go. Life is good. That's how you come up with the domain. If you have repeated values, don't write them more than once. And that's it. That's how you do those problems. So if you have any questions, please let me know. Otherwise, I'll see you in class.